Dear students, welcome to the online class for the subject Power System Analysis and Stability. In the previous class, we have discussed about the derivation for how to solve the problem using NR method. So, we have derived Jacobian matrix and the elements of the Jacobian matrix. In compact form, we have derived the equation, and then today we are going to discuss about the algorithm of Newton-Raphson method. So, when we are comparing this NR method to GS method, in both the methods, the first step itself we have to form the Y-bus matrix, that is admittance bus matrix. So, in algorithm of NR method, the first step is form Y-bus matrix. Then the second step is note the specified values of modulus of Vi and delta I at all PQ buses and delta I at all PV buses. In the absence of any other information, assume modulus of Vi at all PQ buses equal to 1 plus J0. Calculate Pi, that is real power for ith bus, and Qi, reactive power for ith bus for all PQ buses, that means for all load buses, and Pi for all PV buses, that means PV bus, the alternate name is generator bus. So, except slack bus using the formula Pi is equal to summation of j is equal to 1 to n modulus of Vi, modulus of Vj, modulus of Yij, cos of theta ij minus delta I plus delta into j. Then for Qi, that is reactive power of the ith bus, the formula is minus summation of j is equal to 1 to n modulus of Vi, modulus of Vj, modulus of Yij, sine angle of theta ij minus delta I plus delta j. Then calculate del Pi and del Qi for all PQ buses and del Pi for all PV buses, except the slack bus using del Pi equal to Pi specified minus Pi calculated, or we can write it in another form as like del Pi is equal to modulus of Pi power k plus 1 minus Pi power k. So how we can take this equation is present state. We can consider k plus 1 is present state and Pi power k is nothing but previous state. So del Pi is equal to present real power of ith bus minus previous real power of ith bus. Like that we can assume. Del Qi is equal to modulus of Qi power k plus 1 minus Qi power k. Calculate the elements of Jacobian matrix J1, J2, J3 and J4. See, we have derived this equation earlier, the linear simultaneous equation. The matrix del P del Q left hand side is equal to J1, J2, J3, J4 Jacobian matrix into del delta, then del of modulus V is solved. The new voltage magnitude and phase angle are computed from using the equation delta I power k plus 1 equal to delta I power k plus del delta I power k, that is change in this delta I value or small del value. Then Vi power k plus 1, modulus of Vi power k plus 1 is equal to modulus of Vi power k plus, there is a change in, small change in delta Vi power k. The process is continued until the residuals del Pi power k and del Qi power k are less than the specified accuracy. Modulus of del Pi power k is less than or equal to epsilon s. Then similarly, modulus of del Qi power k is also less than or equal to epsilon s. So this total 8 steps includes the algorithm of Gauss-Seidel method. So next we can go and solve the problem. See the figure. The figure shows one line diagram of a simple power system network with generation at buses 1 and 3. So we can see the round symbol. So inside that we can put an alternative sinusoidal signal so that it indicates that it is a generator bus. And here we are having 3 number of buses. See, the bus number 1 has been represented here, 2 has been represented here, and 3 has been represented here. So this power system consists of 3 bus network. And here first bus and third bus are generator bus. Second bus is nothing but a load bus. Why I am telling the second bus is nothing but a load bus means because the arrowhead is there, it is projecting outwards. The magnitude voltage at bus 1 is adjusted to 1.05 per unit magnitude, and our magnitude at bus 3 is fixed at 1.04 per unit with power generation of 200 megawatt. A load consisting of 400 megawatt and 250 MVAR, that is reactive power, is taken from bus 2. Line are marked in per unit on a 100 MVA base, and the line charging susceptances are neglected. Obtain the power flow solution by a Newton-Raphson method. So the problem we will discuss after solving the problem in Gauss-Seidel method. So in in next class we will complete the problem in Gauss-Seidel method, and then we will come to problem solving in NR method. So that only you can feel little bit comfortable in problem solving. In Newton-Raphson method of problem solving, you have to calculator using radian mode, so that you can solve the problem using NR method. So once we will complete the problems in Gauss-Seidel method, and then we will come to NR method problem. Thank you.